Hello, my name is Eldeeb, and I am a doctoral student in the University of Oulu in Finland. I am a research assistant in the Machine Type Communications group in the Center for Wireless Communications. In this video, I will present this journal paper, a learning-based fast uplink grant for massive IoT via support vector machines and long short-term memory. It was published last summer in IEEE Internet of Things journal. The existing resource allocation techniques in 4G and 5G based on the random access suffers from several problems when we use them in IoT networks and machine type communications. It has major problems such as high signaling overhead due to the short packets and high delay due to the forehand shake procedures in the random access, and it may cause some problems in critical applications in ultra-reliable low-latency communication and several collisions in massive machine type communications when we have a large number of devices. So in this paper, we present a new resource allocation techniques based on machine learning. First, we present the system model. We assume that we have a single base station, a couple of IoT devices. Each device can be active or silent. Each active device can be on data or alarm state. Data state is ordinary packet, and alarm state is a higher priority packet, and it occurs because of a sudden event. We model this system model as a coupled Markov modulated Poisson process, which characterizes by 4 states. The first state is the startup, where all the devices are starting to work, and afterwards some devices are tending to transmit data packets. Afterwards, a sudden event happens due to a background process or event in a certain position in the network, causes the nearby devices to send a higher priority alarm packets. Afterwards, those alarm packets, those devices that send their alarm packets become silent. A more congested scenario or a massive scenario where we have more than one event happen at the same time. We have here in this example 4 events. This causes the more devices to send or to transmit alarm packets. In the proposed work, we first predict the quality of service of each device, which device has higher priority than others at each time. Afterwards, we predict when each device is active or silent, depending on the statistics in the past. And afterward, we schedule the devices and do the resource allocation. To classify the devices according to data and alarm device, or to predict the quality of services, we use a couple of algorithms like the support vector machine based on polynomial and radial basis function. We use artificial neural network, decision trees, and random forests. And the support vector machines based on the radial basis function has the best results in terms of precision and recall, accuracy, and F1 scores. Afterwards, we predict which device are active or silent at a time. We refer to this as a time series prediction, and we use a long short-term memory architecture. Afterwards, we schedule the devices according to the classified devices and the predicted active or silent devices. We divide the time axis into 2 states or 2 phases, the training phase and the prediction and correction phase. So in the training phase, we gather data from the past to be used in our algorithm. And in the prediction phase, we predict the active and silent devices, and we correct any sort of errors to use clean data for future prediction. So we test our algorithm compared to the existing resource allocation techniques. First, we simulate the total throughput, and as we can see, the predicted fast uplink grant has the very efficient throughput compared to the genie aided or optimal model where there are no errors, and it outperforms the existing grant-based random access, and of course it works better than the random allocation. Then we simulate the maximum access delay, where the proposed algorithm outperforms the grant-based random access, and it also works near to the Gini aided. Finally, we plot the average access delay, where our proposed model is working efficiently in both cases, the one background process case and several background process case, and it also outperforms the existing techniques. If you have any questions, don't hesitate to contact me, and thank you for listening.